All right, so for question number 16, it's basically giving us this mystery compound that's consisting of carbon, hydrogen, and oxygen. And we're making some carbon dioxide and water. So what I always like to start with on these are our little mystery formula. Okay, when it has the oxygen, we have 3 little mystery subscripts that we're going to be finding. And we're going to combust that in some oxygen to make carbon dioxide and water. And then I like to pull all of my numbers and put them underneath your different compounds so you know what you're dealing with. So the actual compound itself is a 12.915 gram sample. The carbon dioxide that we're able to obtain is 18.942 grams. And the water is 7.749 grams. Okay? And so the key to these types of questions, the combustion analysis questions, is that we make the assumption that all of this carbon becomes carbon dioxide, all of this hydrogen becomes water. That's the big assumption. And then from there we can figure out the oxygen or the nitrogen, whichever one is given to you. Okay? So we're going to start with our carbon dioxide, and we're going to figure out the grams of carbon involved there. Okay, or how many grams of carbon were created, because we know that all of it came from this first formula. So we're going to have our 18.942 grams of carbon dioxide. I'm going to make my railroad tracks, do some dimensional analysis, bring my words down to the right. And I know that we're going to be converting into moles. So I know that 1 mole of carbon dioxide has a molar mass of 44.01 grams. And then I'm going to bring those words down to the right. And this is the part where we're going to be turning into moles of carbon. So we're trying to figure out from our formula how many carbons are involved in this carbon dioxide. And there's 1 mole of carbon dioxide has 1 mole of carbon in it. I'm going to take it one more step, and we're going to say 1 mole of carbon and the molar mass of carbon. When you get that all typed into your calculator, you should be getting 5.169 grams. And so that's our first value. So this is our carbon. Okay, so the next step is we're going to take our water value. We are going to, here we go. Okay, we're going to take our water value, which is the 7.749 grams. And we're going to try and figure out how many grams of hydrogen are involved there. So we're going to take that. I know that 1 mole of water has a molar mass of 18.02 grams. In this molecule, we're comparing our moles of hydrogen to moles of water. So I know that 1 mole of water has 2 moles of hydrogen. And then finally, we're going to go 1 mole of hydrogen is 1.008 grams. Okay, when you get that typed in, you're going to find it to be 0.8669 grams. Okay, so now we have our hydrogen. And so on number 14, this is where you could stop and then just go right into empirical formula. But on number 16, we have the oxygen that we also have to figure out. So we're going to now use this little value that's given to us, our sample size, and we're going to figure out how many grams of oxygen are obtained, okay? Or are coming from that empirical formula. So we've got our total sample size, 12.915 grams. I'm going to subtract my grams of carbon, the 5.169 0.169 minus my grams of hydrogen in order to figure out my grams of oxygen. So again, this is total minus grams of carbon minus grams of hydrogen to get grams of oxygen. And so when you subtract it, you get 6.879. Okay? Okay, so the next step that we're going to do is now we're going to run through our empirical formula steps. And so remember, we have to take our grams, convert all of them to moles, and we usually do that by dividing by the molar mass. Once we have that, then you're going to divide by the smallest. And then you're going to make your subscripts from those numbers. Okay, so knowing this, we're going to have for carbon 5.169 grams. I'm going to divide by its molar mass to figure out the value in moles. And so for that one, you should be getting 0.43039 if we're following sig figs. And then for hydrogen, you had the 0.8669. We're going to divide that by the 1.008, the molar mass of hydrogen, in order to get 0.86002 moles. And then finally, we have our 6.879 grams of hydrogen, of oxygen that we're going to divide by its molar mass, 15.999, to get 0.42997 for its moles. Okay? All right, so now that I have moles of everybody, now I'm going to take those values, divide it by the smallest. So my smallest is 0.42997. You could probably figure it out without even typing it into a calculator, just kind of looking at the general number. So this top one, you should be getting approximately 1. The second one, you should get approximately 2. And the last one, you should get equal to 1. Okay? And so your answer here would be CH2O. And that's it.